Okay, so what we want to do now is discuss how the frontal plane control, the hip and the subtalar joint contribute to gait, and we also want to talk about how the pelvis movements help or assist with gait. So let's start with pelvic motion. And so we can see here we have frontal plane pelvic motion, sagittal plane in the middle, and then transverse plane to the right. And what we notice first is that when we're in single limb support in the frontal plane, there's a slight drop in the pelvis on the contralateral side, or the limb advancement side. And at some level, that's counterintuitive because it's actually lengthening or moving the swing limb to the ground, which could contribute to tripping. But it has two advantages, and one of them is it smooths out the trajectory of the center of the mass, which decreases energy cost. Okay, and it also is coupled with hip abduction on the stance limb, which in the frontal plane, which we'll talk about in a minute, which helps shift the weight onto the center of mass onto the stance foot. So now we'll switch to the sagittal plane. So in the sagittal plane, what we can see is that when we're in double support, the trailing limb, there's an anterior tilt, and in the advancing limb, or the limb that has initial contact at that point, there's a posterior pelvic tilt. And so the kind of the relative difference is about 7 degrees. And so it's clear that this 7 degrees, without it, we would have our stride length would be lower. We wouldn't be able to get our foot as far back on the trailing limb or as far forward on the advancing limb. So that adds a little bit to forward progression. And more significantly, we can see this transverse plane motion. So if we imagine that pelvis perfectly horizontal or perpendicular to the forward progression, we would get all of our stride length from the hip and limb extensions that we have. So here's the right limb initial contact and the left limb trailing toe-off point. So the start of double support phase. What we can see is that if we add some rotation, so if we rotate the pelvis toward the advancing limb, we get this increase in forward progression, which is significantly associated to improving stride length. And so this is just reiterating that point where here you're going from this rotated position here to here, and you can see how the pelvis rotates some, and that small 10 degrees of rotation, we get this kind of delta L improvement in forward progression. So here we have frontal plane control, and this is an excellent way to start thinking about frontal plane control, where you have just bilateral stance. And so in bilateral stance, you basically don't need much hip abductor or subtalar joint activity, and essentially we know that the knee and the ankle don't contribute much to frontal plane control because they're mostly sagittal plane joints. And so I'm thinking about it just in general. We know that the hip has 3 degrees of freedom, is a very powerful muscle, sets associated with it, and that the subtalar joint has a 1 degree of freedom and relatively smaller muscles and control. And so just as a theme, what you think of is in terms of balance control, big perturbations and strong ability to control the trunk at the hip. But the subtalar joint is more associated with fine-tuning, which we can connect to adjusting to different ground surfaces, okay, and very minor adjustments in frontal plane control. All right. And so with that in mind, we can look over here, and as we go from single leg stance, what we can notice is that the big stabilizer of the trunk will be the glute medius, as we shift the center of mass over the base of support, which would be the foot. And then if you stand on one leg, you'll notice you kind of wobble a little bit. Well, that wobbling is the fine adjustments and control that would be executed at the subtalar joint while the glute medius stabilized the trunk. So taking that same concept here, let's focus on these footprints to the right. And what we can see is that there's these kind of footprints which represent, right initial contact and a subsequent right initial contact. And then here's the left step that we can see here. Here's one step and then a stride. And what we can follow here is the path of the center of mass as we walk, and we notice that the path of the center of mass is essentially sinusoidal in shape and shifting from one side to the other. So it's going during single limb support. The key is that it has to be within the foot, and so then it's going to transition from being within the foot to the opposite foot during this single limb support on the other side. And so we can just kind of trace the center of mass movement here quickly, and we can see that basically at initial contact, or the initiation of double support, the center of mass would be exactly in between the right and left limb. So it'd be here as we went from the right to the left, and then it's here as we go from the left to the right. So it's exactly in the middle. Okay, and then as we transition over to the stance limb, and we'll use this example here, as we transition over to the right stance limb from the left here, what we're going to see is that just like when we were in standing, we're going to get we have to do hip adduction to move this center of mass point over to the hip, or to the knee, to the footprint on the right side, to get it in within the base of support. And then on the trailing limb, we would need hip abduction, during push-off to shift that weight over to the contralateral limb where we had initial contact. Okay, so let's just kind of look at this graphic again here, which shows us the hip angle, during a gait cycle, and we can see that it matches up really well with the center of mass projection. So at initial contact on the limb that is going into single limb support, we can see that there's a quick adduction motion that's then accommodated by, during single limb support, just a real gradual shift to the opposite side. And then as we go into double support, there's a relatively quick and large, about 10 degrees of abduction to unweight that limb and push us over onto the contralateral side during single support. Okay, and then basically during swing, we have a gradual return to neutral. Okay, so that's the control in the frontal plane and some kinematics of the pelvis.